Today we're going to be talking about what's called a normal distribution. Now, a normal distribution refers to data in a set. The other day we talked about data with mean, median, mode, standard deviation, range. We were talking about that with reference to data. Another concept of data is a distribution, and the distribution is how the data falls out, like how is it distributed in relation to the mean. So the normal distribution is modeled by a bell-shaped curve, which is also called a normal curve, that is symmetric about the mean. So that means you have as much or as many data points above the mean as you would have below the mean. So symmetric about the mean. So a normal distribution, when we look at a curve, and we're talking about how far the data is away from the mean, if we draw it as a curve, as you see below here, the total area underneath that curve is 100%. So all the data would fall underneath that curve. Now, within one standard deviation below or above the mean, we would have 68% of the data there. So if you look at this picture down here, it says x bar, which again means mean, minus the standard deviation. Minus one standard deviation is right here. And x bar plus one standard deviation is right here. So what this is saying is that 68% of the data is within this range between one standard deviation below the mean and one standard deviation above the mean. Now if we go out, the mean minus two standard deviations and the mean plus two standard deviations, that is 95%. So 95% of the data is within two standard deviations. And then finally, we have three standard deviations below the mean and three standard deviations above the mean, and that would be 99.7% of the data falls within that range. Now you can break that up even further because normal distribution is symmetrical around the mean. We can break that up a little bit further, where what if I just want the data between the mean and one standard deviation below it? So what if I just want this section? Well, see, this section is just 34%. What if I want just the section between one standard deviation above and two standard deviations above the mean? What if I just want this part? Well, that part is 13.5%. So we use the mean and standard deviation to figure out how much of our data falls within this range. We don't know anything else besides the specific, or about the specific data points. We just know how much of the data would fall within that range. So what we'll do with these examples is first we're going to use it in terms of the mean and standard deviation, and then apply that to real problems. So it says a normal distribution has a mean of x and a standard deviation of lowercase sigma. For a randomly selected x value from the distribution, find the probability that x is less than or equal to the mean plus three standard deviations. So this right here, what that means in normal people words, less than or equal to the mean plus three standard deviations. So what we're going to do is we're going to look for this symbol down here. Okay, it is right there. Now we want everything smaller to the left of that. So we want all of this area to the left. So we're going to add up we're going to add up these numbers here, and that will give us the probability that our data is less than or equal to the mean plus 3 standard deviations. So 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, and that equals 99.85%. Now that was a lot of adding we had to do. What we could do instead is know that it's 100% under the curve. We know that we highlighted everything besides this one right here. So if we do 100% minus what we didn't highlight, minus 0.15, that gives us 99.85. So using the complement is sometimes easier than doing what we were asked to do. So instead of adding all of that, we could have just used the complement. All right, then letter B, we have the probability that the mean minus 2 standard deviations is less than or equal to x, which is less than or equal to the mean plus 2 standard deviations. So again, what this means in normal people words is that I want the area between the mean minus 2 standard deviations and the mean plus 1 standard deviation. We'll abbreviate that SD. So we're going to find these two things below, and we want the area in between. So we want all of this. So now we're going to add 13.5 plus 34 plus 34, and that's 81.5%. So it's a lot of matching and then just understanding what the symbols say. Less than means I've got to go to the left, greater than I got to go to the right. And then if you have a compound one like letter B, we want that in between. All right, so on the next page, what I want you to do is I want you to try these. All right, so let's check these out. Letter C, the reason why I went to the right is because it says x is greater than, so I wanted to go to the right. And I just had these two spots here because I found where this is right here, and then I went to the right and added those up. 2.35 plus 0.15 is 2.5. And then for letter D, I want everything that is bigger than x minus the standard deviation and smaller than x plus 3 standard deviations. So I marked those, and then in between, when I added all those up, I got 83.85. So there was more of a glorified matching thing and then a shading with some addition afterwards. Now we're going to use that to actually interpret data. So here it says the math scores of the 2004 SAT exam are normally distributed with a mean of 518. So what that means is that x bar is 518 and a standard deviation of 114. So this is my standard deviation. So if I translate that to this information up here, my middle one is going to be x bar. So if I go down here, I can label the middle one the mean, which was 518. Then to the right, I'm adding one standard deviation. So 518 plus 114 is 632. So that means this one is 632 because I'm adding one standard deviation. That's what this is saying right here. The mean plus one standard deviation. The next one says the mean plus two standard deviations. So if I take that 632 and add another standard deviation, I get 746. So that means my next one is 746. Then if I add another standard deviation, I get the mean plus three standard deviations. So 746 plus another 114 equals 860. So we have 860 right here. Well, what about the stuff that is smaller than the mean? Well, we're going to have to subtract 518 minus a standard deviation. That will give us 404. So again, I took the mean and I subtracted a standard deviation. So 404 goes here. Then I'm going to subtract another standard deviation, get 290. And if I take 290 and subtract another standard deviation, that gives you 176. So this is 176, and this is 290. So this one's asking us what's the probability that our, or what percent of test takers score between 518 and 746. So we need to find 518 and 746. And I want the data between that. So what we're going to do is we're going to go up to our distribution curve and see what percent is this. So we go up here, that was this part to this part. So I'm going to be adding 34 and 13.5. to get 47.5. Now letter B says what a percent of test takers have scores less than 404. So I'm going to use the same numbers because it's the same problem here. 176, 290, 404, 518, 632, 746, 860. So here's 404, and I want the percent of scores that are less than that, so I want this part over here. So I'm going to go up to my picture, and that 404 was minus one standard deviation. So in my picture, here's the mean minus one standard deviation, and I want everything smaller than that. So I'm going to add these three up. So 0.15 plus 2.35 plus 13.5 is 16%. So 16% of students scored less than 404. All right, let's go to the next page. It's going to be the same values. So let's copy that down real quick. The same data from the previous page. So 176, 296, 404, 508, 632, 746, and 860. And then over here, the same thing. Okay, and then once we get this down, I'm going to have you try these. So letter C, about what percent of test takers have scores between 404 and 632? And then letter C, what percent of test takers have scores greater than 746? So go ahead, try this, and then once you're done, unpause the video, and we can see how you did. All right, so for letter C, if we take those values, this picture, and apply it down here, it corresponds with the mean minus 1 standard deviation, and the mean plus 1 standard deviation. So we add those up. 34 plus 34 is 68%. Okay, now, letter D, we want greater than 746. So I'm going to the right. So if we apply that down here, that's the mean plus 2 standard deviations. I'm going to add those two values together to get 2.5%. Okay? So you really need to know how to use that chart below and match things up. All right, then example 3, it says the typical amount of sleep per night for college students is normally distributed with a mean of 7 hours and a standard deviation of 1.7. So 1.7 is my sigma, and 7 is my x bar. Well, about what percent of college students sleep between 5.3 and 8.7 hours? So I'm going to use this picture up here. Our mean was 7, and then I'm going to add 1.7 each time. So 7 plus 1.7 is 8.7. 8.7 plus 1.7 is 10.4. And 10.4 plus 1.7 is 12.1. And then if I subtract 7 minus 1.7, that's 5.3. 5.3 minus 1.7 is 3.6. And 3.6 minus 1.7 is 1.9. So you have 1.9, 3.6, and 5.3. So this one says about what percent of college students sleep between 5.3 and 8.7 hours. Well, 5.3 is here, 8.7 is there, and I want in between that. So I'm going to add up this area here. So 34 plus 34 is 68%. And then letter B, what is the interval in hours of sleep for 95% of college students? Oh, that's a little different. Well, here's 95%, and that's going to be the mean minus 2 standard deviations to the mean plus 2 standard deviations. So over here, we have the mean minus 2 standard deviations is 3.6, and the mean plus 2 standard deviations is 10.4. So that means that 95% of the students sleep between 3.6 and 10.4 hours. So again, this concept seems very simple, but you got to know what these symbols mean. That that X bar, that is your mean, your average, and that little sigma symbol, the R, the squiggly line or weird looking R, that's your standard deviation, and you have to be able to add that or subtract that to fill out this chart. So go ahead and try these on your own. Try your assignment. Thanks for watching. Make sure to like and subscribe.